the 360 on Energy and Carbon podcast, hosted by 360 Energy. Today, we have our second guest on the 360 on Energy and Carbon podcast for another two-part series. Jon Norman is a professional engineer and economist with over 20 years' experience in the power industry, management consulting, and government. His career spans both the energy and environmental sectors as well as project management. Jon is currently president and COO at Hydrostor Inc., an internationally leading company in advanced compressed air energy storage. Now let's get into the episode. Welcome back, Dave and Jon. I'm excited to see another new face today. Jon, thank you for joining us.
Thanks, Lysandra. I'm very happy to be here. And thanks, Dave, for contacting me. It's great to see you again.
We have quite a few questions prepared for you regarding Hydrostore, the future of the electricity grid, carbon, and more, but I thought it would be best if we could start off with getting a bit of a career background from you.
Sure, yeah, happy to do so. So, I guess I have an interesting career path, but it's always been motivated by the same desire. Like I've really been focused on environment since an early age. I can point to David Suzuki, strangely being the reason for that. I watched The Nature of Things religiously when I was a kid, and it really inspired me to sort of devote my career to environment. So that was always a big core driver for me. So I actually went into engineering to look at like, how do you solve problems of the environment? How do you clean up contamination and do that sort of thing? And that's my background. I'm a water resources engineer. And I actually worked as an engineer, an environmental engineer for years. And I started getting frustrated by, like dealing with the end of pipe kind of solutions. Like, how did this problem get here in the first place, right? And that's when I really decided to migrate a bit more into the policy world. And so like I sort of intentionally moved on and did my master's degree focused on economics, and then actually worked for years with the Ontario government. So that's kind of when I transitioned over a bit to the power sector. I had actually like co-founded and run a renewable energy co-op that was way ahead of its time, like not in a good way. Like ahead of its time in the sense of not being able to really succeed. So I had some background in it, but I started working with the Ministry of Energy in Ontario, and it was a great time to be there because they were trying to shut down the coal plants at the time. And eventually, as I migrated into more senior roles in the organization, I led that program, which was a really neat experience, and then eventually moved on to other things at the ministry, including leading the smart metering initiative, managing all the grid policy around the Green Energy Act. So lots and lots of different things. Part of the reason I moved on from there was I did want to devote my career sort of to climate change and energy. Like that's really where my background is. And I just wanted to start doing things more internationally. And a good platform to do that was Brookfield, especially based out of Toronto. So that's where I went after that. I already knew some folks there. It was a really cool experience. I led their commercial development in North America. I led their revenue and power marketing in Europe. So a lot of really interesting international stuff. Lots of funny stories about, like I was a registered lobbyist in DC and Connecticut and Massachusetts, and California. And like all these places are unique, and the stuff you see in the New York Times is all true. And in a way it's worse and crazier when you're on that side of it. But it was really good experience. And I sort of intentionally came over to Hydrostore to build something up, right? To actually work in the innovation space and take all this experience I had kind of gotten in the sector and build something a bit more from scratch. So that's kind of where I am right now.
That sounds like an incredible career. Could you explain what Hydrostore is?
Yeah, so we're a long duration energy storage company. So it kind of we effectively make batteries in a sense, but we use mechanical means only. So we actually use compressed air as our storage medium. And that means what we're doing is we're taking off-peak electricity, we're running that through a compressor, and then all that energy is stored in the form of air. And that air is stored at high pressure underground. And when the grid needs it, you can store that for a really long time. When the grid needs it, you run that air back through a turbine so that it then generates electricity when it's needed. This has actually existed for quite some time, but Hydrostore dealt with a couple of major limitations of compressed air energy storage. One is that you always need a heat source. So compressed air energy storage to date has always burned natural gas as that heat source. So we just actually take heat that's already generated in our compression process and we store that. And then we just use that into the generator when the turbine's generating. That sounds simple enough, and in a way it is, but it's never really been done before, especially at a utility scale. So that's kind of like part of the nature of innovation. And the other thing that we can do, because of the way we've integrated it together, we can flexibly site our projects where it's required. So we're not like traditional compressed air required so much volume that they had to use salt caverns and other sorts of infrastructure that already existed. We actually construct a cavity underground and in bedrock and use that to store the air. And the reason why this all works is because we had a slightly different starting point as an innovator. It's hard enough to innovate in the power sector, and I'm sure we'll talk a bit more about that. But if you're trying to innovate in the power sector and create a lab experiment from scratch and then bring that to fruition commercial, it's almost impossible, right? And there's a lot of companies that have gone belly up in that process. We've intentionally built ours around existing supply chains and just existing equipment and existing approaches to this cavern construction that they use in the oil and gas sector. And we just integrate it together. So it's actually quite simple, and utilities can get their head around that. And we've lined up, really, really big $250 million performance guarantee facilities and this kind of stuff to just help check off all the risk items and just allow utilities to be able to deal with that. And that's what makes us kind of special. We're a pretty unique resource in that we're kind of like a pumped hydro resource where, it's the same sort of principles and you have the same rotating equipment that the grid really likes, but we can flexibly locate, which is a huge advantage. And so that makes us a pretty unique pathway, unlike other storage technology.
Yeah, when I first read about Hydrostore, I was very amazed. I think it's incredibly innovative and such an interesting concept. What has the diverse work experience that you have provided that motivates you to become a leader for a successful startup such as Hydrostore?
Yeah, I mean, as I was saying before, really like the big fundamental driver is my passion for the environment and social change generally. Like that's what's always driven my career. It's never been about a paycheck per se. And that's probably actually a good approach for anybody, right? Like if you're doing what you love and you're passionate about and you're going to put effort into that, then the money will follow. Like success, however you measure that, will sort of follow. So I've always been focused on that, and that's why I've jumped around at certain times when it almost seemed illogical to do so. But it's because I really want to change things. What's helped me with Hydrostore is just like that diverse experience I was talking about before. I just have a very deep understanding now of the power sector. And for Hydrostore, that was pretty critical because if you think about what they are, and this is true of all startups, right? Like you don't have everything you need in the beginning. And so there were a bunch of engineers who like are mechanical engineers who came up with the way of integrating this together and thought, oh, hey, this thing will just sell itself, right? Like it's kind of like we built this great vacuum cleaner and now we can it'll just market it to Canadian Tire and it'll sell. And clearly it's more complicated than that. And also the issue that we have is we need scale. Like we're not a small scale technology. We're hundreds of megawatts scale. Because that's where we're economic. That's just the nature of our approach. Helps us replace gas plants and that kind of thing. But it's a very unique form of development. And that's exactly what I've done for years and years and years. So I know how these electrons are sold and what's required and the actual regulatory environment that is necessary. And I have an international experience. I know how these power markets sort of differ between different jurisdictions. And so I helped kind of build up our growth internationally and our approach to actually selling ultimately or developing. We even self-develop our own projects now to move them forward. For me, that was really important because then I'm sort of leveraging my career learnings into building something new rather than if I'd stayed at Brookfield, for example, it's a great company, it's a good job, but it's a bit more passive, right? It's about creating the shareholder value, which is a very valuable thing to do. But it's always a race to be, I wouldn't even say race to be second. It's a race to be third or fourth in that kind of world. Whereas I wanted to be a bit more on the leading edge cusp. So that's where I was coming from with it.
John, I'm so delighted that you have joined, because I know our listeners are going to pick up a ton of golden nuggets from you. And listen, I want to just comment on the statement that you made, because I say that frequently, is that, it's really important for people to go and do what they're passionate about. And I've stressed the money will follow, because you'll become really good at it. So I'm so glad you brought that up as a piece for our listeners, because I think it's a very important piece. I see many people do jobs that they hate, and that's a pretty tough thing to go through life doing that. So thank you for sharing your wisdom on that. Because of your diverse experience, can you share with us what you think are critical principles in a marketplace that will allow innovation to advance and be implemented at a fast pace? And John, you're welcome to shut out any jurisdictions that you think that have set the proper foundation based on your experience in the workplace and the energy markets.
Yeah, I mean, it's a really good question, and it varies greatly, I would say, depending on the marketplace you're talking about. So, I mean, to the extent we're talking about electricity in the power sector, I mean, one thing that needs to be recognized is that innovation is just very difficult in the power sector, like much more so than other sectors, right? So the reason you see kind of like, a lot of successful startups like the unicorns and that kind of thing, they're all tech startups, right? Like IT, that kind of stuff. That stuff scales really quickly, right? And it doesn't require actually that much investment to get to that point. Whereas if you're trying to innovate on massive infrastructure in a really, really regulated conservative sector, generally, to be completely honest, that's almost entirely failed, right? that hasn't really worked. What I will say, however, and why I'm in this job right now, is that that's changing rapidly, right? The electricity sector itself is changing rapidly, that I'm sure we'll also talk a bit more about. And so that's driving the need for, you just can't keep doing the same old, same old. But having said that, the power sector is built on conservative, regulated principles. It's very safety focused for obvious reasons, and then nobody accepts a loss of power. So like, there's no there's no acceptance of any risk really. And what that means is that it's difficult enough to finance just a traditional merchant power plant that's new on the system, never mind one that is a new technology that's doing anything beyond a pilot. So, like, to your question, Dave, about principles, and that I think would be kind of important as we innovate more in the power sector, and we need to. So the first is that the regulators themselves need to come into the 21st century, and they aren't. I don't mean that entirely pejoratively, but we're way behind, and not because there's dumb people working there or they're lazy. It's just that's the way they're set up, and so the institutional structure is a bit, frankly, screwed up. And there are leading regulators actually who are really pushing against that and are really trying to create something that's much more future facing. How do we just not build the same old things? How do we not just build the same old fossil plants? How do we think about adaptation? Like, what are we going to do that's different? And, I think those regulators are in places like Australia or California to some degree. New York has been pretty, progressive as well. But even as I say those, I kind of cringe in the back of my head, because they're still like they're struggling massively to really change what it is that they're doing. And what I mean by this is they can't just act as a brake. Like, their role in the past has been utilities are incented to increase their rate base, and therefore we just need to say no, 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 okay, right, and no, no. And that doesn't work anymore. The utilities now are gun shy. They don't want to bring new technology forward and not be able to recover the costs. So they need to provide the incentives to allow the risk taking. That's, I guess, easier said than done. But there's a couple of things you can do in the near term that are actually really, really helpful to get, new innovation on. Like one big one is to actually create mandates for it. And that can come from government, and then regulators need to respond to that. An example of this is California, right? Where they've created mandates for new attributes. But the attributes, even though these are needed, the attributes are long duration storage. But that means that's coming from something that is probably innovative, right? It could be pumped hydro, but there's only so many options for that. And that means they're now saying, hey, we'll ask for 1,000 megawatts of 8-hour plus storage and mandate utilities to procure that. So the utilities know what they need to face. And that maybe you want to do that long term, maybe you don't. But in the transition period, that's really important. Like getting too hung up on theories of markets and like what we should do long term, and then hoping the market will just respond and that kind of thing, that's not going to work in the time frame we have now. And so like people can criticize California, you guys are always centrally planning and doing this stuff, but the reality is it works. Like it actually creates new experiments and allows for them to be much more progressive than other places. And the things that don't work fall by the wayside, and they move on to the next thing. So I think that can be done much more in the near term. The other thing too is like you'll see regulators and utilities talk about innovation, but all they're doing are pilots. And to me, pilots aren't really the issue. Like a sandbox can help, and there are technologies out there that are in the sandbox stage. But that also means how are they going to get to the next stage where they're at the scale, right? Like, so you already have technologies, Hydrostore included, but lots of others that are ready to scale, but it's the valley of death that's the problem, right? Like how do we go from our 2 megawatt contracted plant with the ISO in Ontario to the cost effective versions of our systems are 200 megawatts to 500 megawatts. So that requires a leap, and it requires assistance, right? Like we need early stage development capital. You shouldn't just spread the funding like peanut butter. Like there needs to be funding available, and then it shouldn't just be, okay, everyone gets like $1 million. It should actually be, what are the outcomes you're going to get from doing this, and how are you going to bring someone past the valley of death? I'm not saying we're the only ones, but like it's just got to be competitive. There's got to be a way of doing that, and financing assistance is really important as well. Trying to deal with getting debt on your project with the traditional sector. I mean, this is something that is well known, and there's been programs before, but they just need to be implemented. Australia has done a lot of that. Like New South Wales is really, really progressive at creating these kinds of programs now and creating contracts in addition to California. But not all jurisdictions are doing that. And so to me, that's like the really low hanging fruit in the near term.
So it's a follow-up question, Jon, and probably something that you weren't prepared for, but I'm going to, just based on what you've said, I think it's just great content. The intent of this is for our listeners so they understand how they can play and what role they can play and how they can optimize their energy usage, their costs. Based on what you've said, and I understand the role and the merits of regulators and what they need to play, but is there things that you think the marketplace could play to help out in the innovation, to help an organization like yourself?
Yeah, I think so. So interestingly, I certainly have thoughts on that. Interestingly, Hydrostore itself is largely a front of the meter technology. So, we can't, like, we're 200 megawatts in scale. So there's very few end users out there that are just like, buying this directly. And that's why I spent so much time focusing on how do you transition kind of the overall grid and get to an end state that makes sense and is actually decarbonized, and you're doing this in a logical framework. But the end users are obviously really important in this. And, there are models that are starting to develop that just allow for greater end user choice. And I think technology has really helped that, right? Because it tends to be complicated. Like, how do you match all these different components to load, or how do you aggregate loads together? And so over the past 10 years, that's actually changed a lot, because there's all kinds of intermediaries out there that are sort of aggregating this and coming up with products that the grid planner can work around, but still allow for the loads to choose, like, when do I want to shut down, or how do I actually manage my load better? Do I put storage behind the meter? Do I get renewables? And so the incentives are then better. And I think you can allow for more of that. Interestingly, what I would say is I think that's actually where there's been the most progress. Like I think we've seen a lot of change there is driven by end users sort of wanting that choice. But those are kind of the low hanging fruit. So like it's the commercial institutional guys, or a lot of them are sophisticated enough that they've been, calling for this for a long time, and it's now being implemented. But we're not there residentially, I would say, it's with very few small exceptions. And the reason I take the residential example is, to me, it kind of comes back to the same points. I'm not sure, throughout my entire career in the power sector, like I've heard the model of, I don't know, smart meters or those kinds of things, or like the BlackBerry, right? And it's going to change the world, and then people do. But the difference with a BlackBerry is, like, you're getting new utility from that device, right? When how can customers who are electricity customers have any more utility than passive electricity consumption that they don't need to think about? Who's asking, other than 5% of people out there, to have more active participation in their electricity? Sure, you can save them money, but they'd like that to happen passively anyways. And the reason I say that is it goes back to, I think there actually needs to be better grid planning and coordination in the areas that I'm talking about, as opposed to hoping that the end users will kind of pick that up themselves.
Yeah, and our point of contention is that we believe if the end user was a lot more proactive and a lot more knowledgeable, that they could take advantage of options if they knew what those options are. And so we're certainly in line with on this same thought.
Well, I should actually say that the extent to which that's facilitated, I don't mean to be so negative on it. To the extent that someone comes up and facilitates that properly, it makes it really easy for someone to choose, kind of like picking a financial portfolio and that kind of thing. Yeah, people will engage with that. Like, and so I agree with you. I don't mean to kind of shut it down completely. I just think it's probably not the only solution. And certainly it's worked in commercial institutional. I think there needs to be more action in residential and so on, like you're saying.
Yeah, John, and I didn't see it as shutting it down. In our view, it's just most people don't know they have options, and they don't know the value of those options. So thank you for sharing. Can you describe the sweet spot that you think Hydrostor solution is best suited for in the marketplace?
Yeah, I mean, when you think about what our technology is, it's kind of like this locatable pumped hydro plant. So you've got scale, it's like 200, 500 megawatts. It's 8 hour long duration, even up to multi-day storage. And so that actually makes it kind of unique in that, other types of storage, like pumped hydro is great, but you can't flexibly locate it and tends to be really controversial. And so getting it built, like the low hanging fruit are already taken out there. Batteries are great, but they're really focused on short duration applications, probably will be useful behind the meter, and have all kinds of limitations in terms of performance degradation. And they're just not serving the same market. They're very different. And what it allows us to kind of target as sweet spots surgically are things like replacing fossil plants, right? So like there's a lot of retirement. Fossil plants are retiring, right? For economic reasons. Like, who's building a new coal plant? Nobody, right? Like Trump comes into power and says, we're going to redo the coal. He has no power over that. No one's building a coal plant. But these things are reaching their end of life everywhere. The low hanging fruit for us are, we can actually surgically site where your fossil plant is retiring, and we actually operate very similarly to that plant. So unlike a solar plant alone, or a renewable plant, or even paired with batteries, that's all asynchronous generation. It doesn't provide system inertia. The grid wasn't really designed that way. So you have all this transmission infrastructure that's in place that's been built around something that's not that, which is not to say it's not transitioning, like it has to. But the solution we have is very attractive because it does provide the same rotating inertia. It operates very similarly to a gas plant. It's just not using any gas, it's using air, right? So you can tomorrow, replace a 500 megawatt gas plant with an advanced case plant. And whether you're feeding it with renewables or off-peak electricity, depending on what the circumstance is there, then Bob's your uncle in terms of the reliability piece. It's very well known to them. So for us, that's a really good low-hanging fruit. The other one that we've been working on in lots of different jurisdictions is alternatives to transmission. The reason why, incidentally, both of those, like fossil plant replacement and transmission replacement, are really well suited to us, you need long durations. So you can't, if you're going to have reliability of a transmission line or a coal plant or a natural gas plant, you can't just have a 4-hour or 2-hour duration solution, because what happens if you need power for 8 hours, right? And grid operators have looked around at this around the world, and they've actually come to, if you look at all their studies, it all comes to the same consensus. They need at least 8 to 10 hours to provide reliable replacement capacity. Interestingly, for political reasons, people like Elon Musk, right? Like the battery industry, some of the states haven't quite gotten there yet because they were pushed to recognize 4-hour duration storage as providing capacity. But in a lot of states, like California, for example, they're finding, this doesn't work anymore. We can't have any more batteries. We need 8-hour storage. That's why they're putting mandates in place. So the chickens come home to roost anyways on that one. But that's why I would say for us, it's really that's our sweet spot right now. That's where we have a pipeline of about 15 projects globally that are all different versions of that application, like transmission replacements in Chile. We've been selected as a preferred reliability alternative by the largest utility in Australia. Again, it's a transmission alternative. And then there's a bunch of places we're working with Ontario Power Generation here to look at and investigate advanced case or technology as a replacement or partial replacement to Pickering, right? Like that's going to go offline. How do you get capacity in Ontario? Same thing with different parts in the US where coal plants are retiring. We're working directly with the utilities to say, how can you use advanced case to replace those plants?
That's good stuff, John. Can you share with us, our listeners, about your company and what role it is playing in helping advance and possibly decarbonize our grid?
Yeah, I mean, I think it does sort of build on the previous question. I mean, to harp on the point that's really important, long duration storage, so like greater than 8 hours storage is a critical enabler to grid decarbonization. Number one. Obviously, your supply sources are going to come from renewable sources and so on, but you need storage to be able to obviously take that sun when it's not shining and wind when the wind's not blowing and have it on the system when it's required. What we found with utilities we're talking to is they actually are finding that initially, like there's benefits to the short duration stuff, because it just helps deal with like fluctuations in solar and that kind of thing right away. So that's valuable. But then it jumps to a long duration need, like at least half a day kind of need, and then into multiple days to really fully enable decarbonization. And that means you're going to need some kind of innovation, or the world's got to become a pumped hydro plant, because you're not going to get to a place where you're just stacking cells and cells of batteries, like even with the cost reductions that they're talking about in the battery sector. So they have their place, but it's critical that you have long duration storage. And so that's directly where we play. There's other folks out there too that are looking at new solutions using different thermomechanical technologies or flow batteries and that kind of stuff. And they all have different strengths and weaknesses, and we have our own strengths and weaknesses. And those are the applications that we're targeting. But you can't do it. You definitely can't decarbonize the grid without the long duration storage over the long run. And that's directly our sweet spot. And that's where our investors are interested and where we've been successful as a company for sure.
Okay, John, I actually want to take you back on and pick out some of the points that you've got with a question, because you've touched some of these, but I think it might be rather nice to put it into one question and answer if we can. And I think the majority of our listeners will, when you talk to them about energy storage, will automatically think of the battery. And as you say, there are certain characters who've, shall we say, promoted the battery in the extreme. And I know that we're interested at a variety of scales of we want better batteries, starting with our smartphone, we want one that lasts longer, through to we want a car that's got long range. So it seems to me that, if you like, a benchmark of energy storage currently is the battery. Arguably, a previous benchmark of storage was petroleum, because that was quite a good high density storage medium that had long term. But taken that most people who are listening to this are going to see the battery as the benchmark storage, how do other storage methods, particularly at a grid level, compare and contrast with the battery?
Yeah, I mean, it's a great question. I think some context is actually important before I even decide the differences. I was talking earlier about innovation and how hard it is to innovate in the power sector. And the reason why batteries have been sort of a new thing that's been able to come onto the power sector was that they had already been proven out in other markets, right? So they weren't even, like, the point being, they weren't developed for a utility scale application, and they're still not. And in fact, some of the progressive investors we deal with, their strong view is batteries as stationary storage is not what they're designed for, right? They're designed for this. They're designed for increasingly cars, as they should be, and they're designed for weight and that kind of stuff. They're not designed for the characteristics that stationary utility storage require. And so what folks like Tesla are doing, to their credit, is they're searching out a new market where they can put batteries that they've developed for this, or for electric vehicles in their case, and put that on in a new application and see if it works. And so it does kind of work. It works for frequency response, and it works for these short duration applications. But it also, I personally, I think, like, a lot of these installations are new. When's the last time your phone delivered on its performance expectations on its battery? Right. It's funny, but it's dead serious, right? Like, it's not, they're the exact same cells. Like, how are these things going to, so sure, there's a lot of talk now, and these things haven't run for decades yet. What's going to happen when you get to that point? Now, I have no doubt you could probably design better stationary storage batteries, but nobody's actually really doing that right now, right? They're just trying to reapply this and put that on the grid. So I think there's some fundamental limitations there, despite all the hype around it right now. Now, having said that, lithium ion has a place. Like, we interestingly enough are developing battery projects, right? Because they actually complement our technology. They're not really a competitor. They do frequency response, fast acting, millisecond changes on the grid. They're pretty efficient at short durations, providing you augment them enough when they degrade unexpectedly. But if you factor that in, then it can kind of work for that application in the right market. So we look at doing that as kind of a first phase project, and then we integrate it with our system. So we provide the long duration piece, and they provide, like, the first hour fast acting response, if that's what the market or the utility requires. And so that's what I would say as an overarching point, is that lithium ion batteries are really good at that. And that's what they'll continue to be good at. And they're modular, and they can probably increasingly do more behind the meter applications, which we might talk about more, but I think there's some limitations there as well. And so they'll have their place, but they're not going to dominate the long duration storage market. And we're sort of at a crossroads right now where, people would talk about long duration storage, and you could see theoretically how it's really important and all this stuff, but the market wasn't there yet. So even when I joined Hydrostore 4 years ago, there was barely a real market for long duration storage. We have good timing in that we were developing our solution and bringing it up to that time period. But now that's really evolving, right? Like, you see New South Wales, you see California, you see Chile pointing out that they need 8-hour, 10-hour, 13-hour storage for different applications. And that's only going to continue to grow. And increasingly, utilities are starting to look and say, well, either we need to put mandates in for long duration storage, or we have to use something they call the equivalent load carrying capacity, which means They actually look at duration limited resources and they say, well, okay, there's so much contribution that comes from 4-hour resources. And then at that point, it maxes out. And then you need actually much longer durations to come in. And that's already happening. And so you're not, what we've looked at, even with cost declines that we're not so sure are actually achievable for batteries, but even with that, we're much more cost effective, even on an installed cost basis than batteries for those kinds of applications. And we're a very long life asset. Maybe my last point on this is one that I don't think gets talked about enough. We, for better or for worse, right, our society has become a little bit of a disposable society. It's, I can't fix my washing machine. Like I have to replace the thing. That's how things work now. That's how the incentives work. It's actually not different in the power markets. So where they tend to be evolving is they're terrified of taking long-term commitments because of the regulatory structure and the things I was talking about before. And they want 10-year periods, or 5 years, even better, right? Like, and so they look 5 years out and they look 10 years out, and then they're paralyzed after that. But what that means is if you have a 30-year, 40-year asset or something that's going to be really, really helpful in the long run on the grid, it's hard to get that value recognized, right? So that's partly why you've seen so many batteries put on the grid as well, because they are just 10-year assets. So you can fully amortize them and just put them on. Even if they're not the best solution, it's easier is kind of why that happens. And increasingly, you're starting to see that shift too, in that people are thinking longer term. There's wildfires raging in California. They can't just have, one resource or hope that their full reliability situation is going to evolve. So they need to think about long-term portfolios as well. So that's changing also. And it's another reason why you're not going to just see batteries. You're going to have a combination of much longer lifespan technologies, whether that's flow batteries, mechanical technologies like ours, or other sorts of thermal technologies as well.
Yeah, thank you for that. I think it underscores a point to me, and it's something that we discuss in our company, is the lack of energy literacy that there is in most countries, in most places. But I feel with what you're talking about there, even people who are quite well involved with the energy sector probably aren't appreciating some of the, not going to even say the subtleties, but some of the important aspects that you're talking about duration of storage, and the fact that the battery is a proven piece of technology, but it's probably not the ideal piece of technology for this purpose for the future. So it's a matter of what right technology in the right place at the right time is the solution we're looking for.
That's all for today's episode of the 360 on Energy and Carbon podcast. Thanks for listening. Make sure to check us out on our website at 360energy.net and follow us on LinkedIn at 360energy Inc. Tune into our podcast on Apple Music and Spotify by searching the 360 on Energy and Carbon. You can watch the video recording and subscribe on YouTube at 360 Energy Inc. See you next week.